We're asked to determine for each x value whether it is in the domain of f or not. And they have our definition of f of x up here. So pause this video and see if you can work through this before we do it together. All right, so just as a bit of a review, if x is in the domain of our function, that means that if we input our x into our function, then we are going to get a legitimate output f of x. But if for whatever reason f isn't defined at x, or if it gets some kind of undefined state, well then x would not be in the domain. So let's try these different values. Is x equal -5 in the domain of f? Let's see what happens if we try to evaluate f of -5. Well, then in the numerator we get -5 plus 5. Every place where we see an x, we replace it with a -5. So it's -5 plus 5 over -5 minus 3, which is equal to, in our numerator we get 0, and our denominator we get -8. Now, at first you see the 0, you might get a little bit worried, but it's just a 0 in the numerator, so this whole thing just evaluates to a 0, which is a completely legitimate output. So x equals -5 is in the domain. What about x equals 0? Is that in the domain? Pause the video, see if you can figure that out. Well, f of 0 is going to be equal to, in our numerator, we have 0 plus 5. In our denominator, we have 0 minus 3. Well, that's just going to get us 5 in the numerator and -3 in the denominator. This would just be -5/3. But this is a completely legitimate output. So the function is defined at x equals 0, so it's in the domain for sure. Now what about x equals 3? Pause the video, try to figure that out. Well, I'll do that up here. F of 3 is going to be equal to what? And you might already see some warning signs as to what's going to happen here in the denominator. But I'll just evaluate the whole thing. In the numerator, we get 3 plus 5. In the denominator, we get 3 minus 3. So this is going to be equal to 8 over 0. Now, what is 8 divided by 0? Well, we don't know. This is one of those fascinating things in mathematics. We haven't defined what happens when something is divided by 0. So 3 is not in the domain. The function is not defined there, not in domain. Let's do another example. Determine for each x value whether it is in the domain of g or not. So pause this video and try to work through all three of these. All right, so first of all, when x equals -3, do we get a legitimate g of x? So let's see, g of -3, if we try to evaluate, that's going to be the square root of 3 times -3, which is equal to the square root of -9. Well, with just a principal square root like this, we don't know how to evaluate this. So this is not in the domain. What about when x equals 0? Well, g of 0 is going to be equal to the square root of 3 times 0, which is equal to the square root of 0, which is equal to 0. So that gave us a legitimate result. So that is in the domain. And what about g of 2? Or x equals 2. What does that give us, a legitimate g of 2? Well, g of 2 is going to be equal to the square root of 3 times 2, which is equal to the square root of 6, which is a legitimate output. So x equals 2 is in the domain. Let's do one last example. So we're told this is h of x right over here. And once again, we have to figure out whether these x values are in the domain or not. Pause this video and see if you can work through that. All right, well, let's just first think about h of -1. What's that going to be equal to? -1, every place we see an x, we're going to replace it with a -1, minus 5 squared. Well, this is going to be equal to -6 squared. -6 squared, which is equal to positive 36, which is a very legitimate output. And so this is definitely in the domain. What about 5? So h of 5 is going to be equal to 5 minus 5 squared. Now you might be getting worried because you're seeing a 0 here, but it's not like we're trying to divide by 0. We're just squaring 0, which is completely legitimate. So 0 squared is just a 0. And so h of 5 is very much defined. So this is in the domain. Now what about h of 10? Well, h of 10 is going to be equal to 10 minus 5 squared, which is equal to 5 squared, which is equal to 25. Once again, it's a very legitimate output. So the function is definitely defined for x equals 10. And we're done.